forward, you've got to use the D-pad with that and press special.
Weird. Oh wait, I can see this room.
I don't know what we're doing.
Oh, it's on now. There's a link in the chat.
I need to be able to see
Oh,
my screen share. Oh, it's gonna be great. Okay.
Wait, I can't. Gosh,
Oh my days. Oh, I'm throwing.
I can hear it on two things now. So what do
Oh
I
yeah,
need?
you want to mute on one of them. No, I don't exist. This is great. This is what it's all about.
No, I'm mute it on YouTube because
Yeah, mute it on YouTube and then
it's
whoa,
in
I'm here.
real time.
Do-do-do-do-do.
Oh god, you can see things.
Yay, welcome to Graph Theory with Jump Ray. Fundamentals. What? Alright, so I would usually ask you what do you know about graphs already, just as like a starting question, but I kind of already asked that. And you were like, not really anything. So essentially what a graph is basically just connect the dots, basically. But a teeny bit more to it. Do-do-do-do. Oh no, I've got Discord open. This is such a throw. Alright. So essentially like just that as a graph, if that makes sense.
That is a graph.
That is a graph. The key feature of a graph is it has nodes. Oh, I actually wish you had have seen some graphs before. Oh wow, I'm throwing so
I
hard.
need to graph. No, dance.
See, oh yeah, so you usually think of graphs as being like this, right? Do-do-do. That makes sense, right?
I mean, I think it's probably got a load on there.
Oh, there's delay.
Yes,
There's
it's
stream delay.
Yeah, it's delay. That's the problem.
All the problems. Sorry, I'll start drawing some things, then we can talk through it afterwards.
Oh, I see. I see.
So this is usually what I
that's
think about
a
with
graph
graphs, right?
looks like.
And essentially you can
Yes.
either have like 2 axes like this, or you can have more axes. You can have like 3 axes. And essentially what a graph
We got
does.
4 kind of.
Yeah, you can keep going. So there's no limit to how many dimensions we have going here. And essentially what a graph is it's a mapping between 2 variables, if that makes sense. So like we might have y equals x cubed plus e to x squared or something like that. Yeah?
Yes.
And then if we had a 3-dimensional mapping, we could, you kind of want to do it as a vector. Oh no, you don't need to do it as a vector. I mean, we're not going to look at technicalities too much, but essentially you can have a mapping between 3 variables. So essentially you map between independent variables for graphs like that, but we're looking at a different kind of graph. Instead of mapping the relationship between variables like that, we're looking at the relationship between different nodes. So in the same way you have x, y, and z here, you have x, y, and z nodes. And instead of mapping them together algebraically, you connect them through what we call relations, if that makes sense.
Kind of.
Kind of.
Kind of.
I think it makes more sense if you like think of examples. So essentially the big idea with a graph is as long as there's a finite number of entities, you can model like anything. So you can pretty much pick any situation as long as you haven't got infinitely many things, you can model it. Because so many things are finitely many things, you can model a lot. So like just name a situation.
What situation?
Any situation. Let's model this situation right now, because that'll be funny. All right. All right, we're going to give this node a J for me and Josh. And
Wow.
that's me and you. And these we're going to give bidirectional relations here, because I can talk to you and you can also talk to me. But if we imagine the other people in your room, that's you and that's Mitu. If we imagine the other people in your room, what are nodes? Nodes are any entity. So a node represents a single entity. And it can be
Who are you
literally anything.
talking to?
I'm talking to you and Mitsu. Have I lost you already?
You and Mittu.
You and Mitsu. Or you and Nor.
Mitsu,
or
Mitsu,
Mitsu,
Mitsu.
or- Can Mitsu see the stream audio?
I'm just playing.
Get off the
He's just
game
playing
with this
video games.
Shafil, man.
Oh my goodness.
I'm just.
Your boy just want to play video games.
You guys are like politics and some Amazon.
It's not a politic. It's a some unweighted directed graph is what we're looking at. Oh, that's so small.
Stop pressing triangle.
Oh no, it's
You
too
press
big now.
triangle. Not when you're in the game then.
Oh, you're not interested in learning about graphs. This is so sad. It's also fair. This is like my biggest fear as a mathematician, that no one will care.
3 viewers, let's go.
Let's go. We have so many viewers.
Should've just
So this is the model we have going on right here. Only we could extend it even further. Let's extend it further. Oh no.
When I whip out this character, it's
Yeah.
game over.
So let's extend it even further. So we've done the social relationship as a graph, but we can actually, oh wow, we can actually go further. I'm going to add another node for the internet.
Same thing.
Internet. Yes. So you and Mitsu are connected directly because you're not going through the internet, but for me, because I am going through the internet. And we've also now got some directed edges going on here. I meant relations. So here we got bidirectional relations because I can hear you, you can hear me. But here we can hear people in the background, but they can't hear us. So it's directional. If that makes sense.
Yeah.
So the essential idea of a graph is that
Same. The purple one is the same as your yellow one.
the purple one's the same as what?
Huh?
What did Mitsu say? Or is he talking about the video game still?
Yeah.
Ah, that's fair enough.
Yeah, Israfil was the same character, but he's just a different color and he's proper annoying.
I wish I could relate
Yeah,
that with a graph.
different.
I should be able to. Oh no, I can. I can do everything with a graph. This is what's so good about graphs.
Yeah.
This is the baseline character called B. And then I have an I for Mitsu's character because it belongs to him. And then we can have a... Oh, what's the mathematical symbol for other? Oh, we can have an M for not. Oh no, we don't do that very much. Exclamation mark.
I've just been mixed.
There we go. It's a graph. So essentially anything with a finite number of entities that are all discrete and you can count them can be modeled with a graph. And that's why graphs are so powerful. So I guess we've sort of spoken about what graphs are and how you can use them. I guess the only thing I want to do before I just end this video, because that's pretty much all I wanted to cover, was the restraints on graphs. So essentially the most important thing is we need to define how exactly a relation works. Like, it's pretty easy to understand nodes. You just have nodes. You just draw nodes if you want nodes. But just want to do one quick definition on edges and relations. You call them edges, called relations. So essentially the definition is a relation has to go from one node on the graph to another node of that graph. So if these are the nodes of the graph,
Yeah.
we can't just do this. That's not a valid relation because it has to, oh, you have to wait for it to update. It's okay. While you do that, I'll draw more. Wait,
Yes.
let me know when it's updated. I'm right, I'll draw a smiley face, you know.
The camera's covering it.
Is it? Oh no. I'm throwing. Oh my goodness, Sam. Where can I go? Go down here.
Yeah, not the bottom right.
There we go. Epic. Alright, so has it updated yet?
Yeah, it's moved.
Alright, so you see this, oh, I didn't put a square. Wait. I'll put a blue square next to what I'm talking about. And then I'll draw some more while I'm waiting for it to update. And just let me know when you can see a blue square, because it means it's updated.
Yeah, I see.
Oh wait, no, it hasn't updated. Oh, it's updated a bit. So essentially where the blue square is, oh no, the camera's completely gone. So that's not a valid relation because it has to go from one node to another node of the graph. So there it's not a valid relation because it's just going off into nowhere. So that is bad.
Yeah.
But the interesting thing is here, and it's like clear that we can go between nodes, and that's all good. But because the definition is that relation goes from one node of the graph back to another node of that graph, you can actually have a relation that goes from the node back to itself, and it's still valid. Does that make sense?
Yeah.
And we call that a loop. So I guess that's the only other bit of theory I wanted to go over. And there we go. You now know everything about graphs. Do you? Did you pick up anything from that or not? I don't mind either way.
I
Blue
picked up
squares.
that politics.
How did you pick up politics? I mean, politics can be modelled with graphs, but that's kind of not the point.
I don't think that's the point of anything.
Yeah, exactly what North said. Who wants to talk
That's
about
right,
politics
don't
when you can
really
talk about
enjoy.
graphs? Oh, I could talk about one more bit of theory, and then we'll call it a day. Oh, I've run out of space. This is amazing. I've done so much edumacation. All right, and talk about different types. Edumacation. That's a Baldi's Basics reference. Excellent video game. I should just play that, to be honest. All right, I'm going to draw a two-way table, and then I'll wait for it to load. Oh, my phone's still not updated with chat. This is so sad. Oh, I can type.
Really?
Yeah, I don't know why. There it is.
Wait, what is it saying on chat?
I don't know. That's why I'm trying to load it.
Oh.
Oh, if anyone's in chat and can ask a question, that'd be awesome. If not, it's fine.
I've typed 3 things.
Oh, have you actually? Oh, I'm such a bad streamer.
Yeah.
What is this combo?
I don't know. What is that combo?
This has some, you're doing it infinite.
Oh, I'm going to reach out in a second. I have to remember where I put my face as well.
No, it's fallen.
I usually
Oh,
go
wait,
in the
that's
bottom
today's.
right. Let's see this.
Show me the CM.
Stream politics, yeah. Oh, I can't even load chat. I'm being called out.
That chipped me out.
All right. So let's look at the wider context of graphs, because why not? So this one's specifically looking at unweighted directed graphs. I guess I'll sort of talk about why I chose to do these over all the 4 I could have done. I'll draw like a purple square. No, I've got to draw something more interesting. Oh, yeah, I'll draw a purple square. Purple squares are cool.
Let's go.
Let's go. Math stream hype.
Wait, how?
Sorry?
How? How is purple related to dream?
Oh, it's not related at all. I just felt like it.
Just felt
Yeah,
green.
these things happen. You want green? I'll do a purple and a green. You don't want green. All right.
No green.
Fair enough.
Green be gross.
Okay, do a giant purple square.
Wait, I can't see purple yet.
Yeah, that's why I'm doing it, so I know when it's updated.
Oh, that's a rectangle.
Oh, you're right. Wait, I can make it a square. You ready for this? It's gonna be gamer. Watch this. Watch this.
Oh.
This is the power of mathematics for you.
You want to see the truth? Huh?
Is it updated yet or not? What am I going to draw for update?
This arrow.
Red circle updates. I've declared that the 2 sides are the same length, therefore it's a square. Mathematics. Because you know when they say not drawn to scale, it's essentially. Oh, I'd have to write that too. I guess I should do it for the meme all the way.
Why don't I remember that green letter? No. It's
There we go.
It begins with an L. I know that much.
L.
That's so sad. The freaking Greek letter you've just drawn.
Ah, yeah. You got to guess what the Greek letter is. This is going to be.
I know what it is, but I don't have to pronounce it. Look.
Think physics. Think about waves. Actually, that's not going to help. It's called lambda. Oh, you put it in chat?
I knew. I got it.
Yeah, you were basically there.
All right. No, that is how you do it. I learned it. I've got a picture on my phone, and that's how I spelled it.
Fair enough.
I know it.
So
do not mess.
here we have the
I'm
4
fine.
types of graphs. So I guess now I'll talk about each of the different graphs. So on the top row, we have unweighted graphs. They're graphs without numbers on the relations. And on the bottom row, we have weighted graphs. So we associate a number with it. And that could be like time to get from point A to B, maybe distance between stuff, or maybe, I don't know, how many times you've seen that person. So for example, on the bottom left, we've got you've seen a person 5 times. Only you saw them, but they didn't see you, which is kind of weird, but that's okay. And then we have directed and undirected graphs. So undirected has no direction associated with the relations, whereas directed says you go to them, or they go to you, or it means you both go to each other. So if there's no arrow drawn it, we call it bidirectional. It means it goes one way and the other way simultaneously, if that kind of makes sense.
Yes.
So you might be wondering, why did I pick the top left one specifically? And basically the idea is that all the other 3 are basically the same thing as the unweighted directed graph. So we can actually show this graph in the top left is actually, all of them are this. So this is a directed unweighted graph because they're both, we could think of them both as just bidirectional. And these ones are also because we can just think about it as that graph but with some numbers thrown on top of it. So essentially all graphs are directed underweighted graphs.
You can't be that one.
Wow. There we go.
Right.
How was that? Was that kind of boring? Was it interesting?
Right.
Did you learn anything?
It made sense.
It made sense. All right, well, it's better than not
Yeah.
making sense, I guess. And we got to
Oh,
learn
yeah.
about lambda, the Greek letter lambda. It's probably the most useful thing you learned in this video, not gonna lie. All right. Well, that's it from me. Anything you want to tell the viewers before we end the stream, though?
Subscribe
Subscribe
to
to Panther.
my YouTube.
Yeah, that'll be. Will it be in description? Yeah, I'll put it in description below Discord. Join my Discord first, then subscribe to Panther second.
Wait, you have a Discord?
I have a Discord, yeah. C_Galaxy. Get some
wait, it's
hot
not a
maths
link.
discussion.
You have to copy it.
Oh really? Oh, am I that
Yeah.
much of a not very good YouTuber? It's alright, I'll fix
Wait,
it.
how do I actually
After
do
this.
that?
Oh my goodness.
Oh god.
Alright, thank you guys for joining us, and I'll see you guys later. Bye.